So hey guys, in this tutorial video we'll discuss on the superposition theory, the superposition theorem. So now under the superposition theorem, uh, when we do have two sources, two voltage source or two current source, there might be three current sources. So uh, if we are to analyze the circuit, we need to do it source by source. So we treat each source individually, and at the end we must sum their effects. So in this case, we have two sources in this diagram. We have two current sources, this one and this one. So now, in order to we have been asked to determine the values of V2. We need to come up with V2. We need to come up with V2 and V1. So to come up with V1, and V2, so we treat source by source. So in this case, we are going to start with the 3 amp source. So the 3 amp source. So in this case, meaning one will be switched off. So we are going to switch off the 6 amp source. So now what we must know is that whenever a current source is switched off, it is replaced with the open circuit. Yeah, so it is replaced with the open circuit, and whenever a voltage source is switched off, it is replaced with a short circuit. So this is a open circuit and this is a short circuit. So I'm going to say let um, 3 amps act on. So in this case, we are going to let the 3 amp source act alone. So that's what the superposition theorem demands. So we switch off one while the other one is in operation. So let us switch off the 6 amp. So switching that off, we get this diagram. Getting this diagram. So here we have to replace with a short circuit. An open circuit. And here we have the current source as usual. So this is 3 amps. Here we do have 10, 5, 2. 4. So we have 4. Then here we have 2. So in this case, we are looking for V1 and V2. So to me, if we are to look at this circuit very closely, so we are going to find out that this part, it is the same as if we are to redraw this, it is not doing any part in our circuit. So it is not doing any part in our circuit. So it is the same as we can remove it. So we can remove it by simply replacing with a resistor. So that resistor, the 2 ohm resistor, it shall be placed here. So it's one on the same. So here we have replaced with a 2. I have replaced with a 2 ohm resistor. So here is V1 and here is V2. This is what we are looking for. So now to come up with V1 and V2, so I'm going to combine these two resistors, the 5 ohm and the 10 ohm resistor, for I know that the 5 ohm is the 10 ohm resistor and the 5 ohm resistor. These two resistors are in parallel. So I'm going to combine them. So combining them, we come up with a resistance of, so we say 10 times 5 over 10 plus 5. So what we get is, we get 10 over 3 ohms. So having that as our combined resistance of the 5 ohm and the 10 ohm, we can draw this circuit. So having combined this, we are going to discover that we are going to come up with this combined resistance of 10 over 3 ohms in series with the 2. So in series with the 2, so it will be in series. So we can add the 2 ohms resistor after combining the 5 and the 10. So we get, so I'll name this R1. So R2 is equal to 10 over 3 plus 2. So what we get is, so we are getting 16 over 3. So up to this point now, I can draw my circuit. So in short, I've combined all these. So I will attach this part to the 4 ohms resistor since this is the remaining. So I can move in that accord. So we are going to say we have this, and here is our current source of 3 amps. Here we have got 16 over 3, and here we have got 4. So this still remains our V2. According to our diagram, this remains our V2. So now in this case, it will be very difficult to locate V1. So that part, it will remain the way it is. We are not going to name this portion because we have combined the resistors. But the idea is that after coming up with a current that is flowing through this, we can work this back. We can go back, we can draw the circuit up to where we started from and locate V1. So that's not the issue. So in this case, to come up with this voltage source V2, we need to come up with a current that is flowing through the 4 ohms resistor. So this is I4. So in this case, I'll say I4 using the current divider rule. So using the current divider rule, we say I4 is simply, so we get 16 over 3 divided by 4. So we get 16 over 3 divided by the total. So okay, I'll use the next. So we get I4 is equal to 16 over 3 divided by 4 plus 16 over 3 times, what is the total current there? So the total current there is 3. So we say I4, our I4 in this case is equal to, the value of the I4 in this case will be equal to, so it will be equal to 12 over 7. So this is 12 over 7 amps. So now to come up, mind you, the question demands us to calculate the voltage. So it's to calculate the voltage V1 there, I mean V2. So in this case, to come up with a voltage V2, we say voltage is equal to, according to Ohm's law, current times resistance. So voltage will be equal to 12 over 7 times so the current, the resistance there is 4. So we say it is 48 over 7 volts. So this is what we get as our voltage. So this is V2. So this voltage is V2. So we have gotten V2 to be 48 over 7 volts. So we can go back and determine what V1 is. So now to come up with V1, let me go back a bit. So we see this diagram. So we know the current that is going through this, and that current is the one that we just determined here to be 12 over 7. Yeah. So we can work this back. So we know that this current is simply 12 over 7 amps. So meaning the current that is going through here, the current that is going through there, it's just a matter of subtracting. The total is 3. So the total in this case is 3, because this is dividing now. So it is going to this portion and that portion. So now, let me just go and redo circuit. So I'll redraw it this side. So I will redraw it this side. So we add first. Then we add this. So we have the current source somewhere here. Okay, so this is 3 amps. Then this is 4. And within this 4, we have got 12 over 7 current. Here we have 12 over 7 current. So these are the things that we don't need to forget. So this is 5, this is 10, then this is the 2 ohm resistor. So now we have the current that is going through there again. So now I'm saying this 3 amps is dividing between this portion, the whole of this portion, and this. So meaning to come up with this value of the current, we just need to subtract 3 minus 12 over 7. So we get 4 over 3, 4 over 7 amps. So that is the current that is going through this portion. So now upon reaching this node or this point of connection, it is going to divide between the 10 ohm resistor and the 5 ohms resistor. So we can do again a current divider, so that we come up with a current that is going through that. So that is simple. We just say, so it is 10 over 5 plus 10 times 4 over 7. So what do we get? So we are getting, so 10 divided 15 times 4 over 7. So what we get is, we are getting, so we are getting 8 over 21. So we are getting 8 over 21. Okay, let me do this again. So what is 3 minus 12 over 7? 12 over 7. So no, we have made a mistake. We're supposed to get a 9 over, so it is supposed to be a 9 over 7. So 9 over 7 there. So meaning even this I'll change a bit. So it has to be 9 over 7. So when we say 9 over 7 times 10 over 15, so we get 6 over 7 there. So we are getting 6 over 7 here. So 6 over 7 amps, that is what we are getting. So having that as 6 over 7, so what we get, we want V2. So V2 is this portion, V2. So in this case we get V2 is, V1. That part is V1. So you have mistaken these two. So this part is V2, okay? So what I'm looking for is V1. So V1 is equal to 6 over 7 times the resistor that is there, which is 5. So we get 30. So we get 30 over 7 volts as our V1. So these are the values that we have gotten. We have gotten V1 to be 30 over 7 volts and V2 to be so my V2 was 48 over 7 volts. So we move. So in this case we are going to switch off. So since we are working with the 3 amp source, so we are going to switch off the 3 amp source and switch on the 6 amp source. So switching off the 3 amp source, we have got this diagram. So we have got this diagram with the 6 amps working, the 3 amps working, but this one has been disconnected. So this is the 2 ohms resistor. So this is 2. We have got the 6 amp source here. Then we have got the 4 amp source, the 4 ohms resistor there. Then this is 5. This is the 10 ohms resistor. So again, we are looking for V1 and V2 when the 6 amps is working. So what we must start with now is what method are we going to use. So in this case, what we know is that this and this, these two resistors are in parallel, and when you combine these two, they are going to be in series with this. So we can move in that accord. We say R1 is equal to 10 in parallel with 5, 10 in parallel with 5, but in series with the 4 ohms. So calculating that, we get the combined resistor of 5 and 10, we get 10 over 3. We get 10 over 3 there. We get 10 over 3 there plus 4. So having combined that, what are we getting? So what are we getting? So we are getting, having combined that, so we must get 10 over 3 plus 10 over 3 plus 4. So we are getting 22 over 3 ohms. So in short, in other words, the circuit that we have remained with, it reduces to this. So it reduces to this. It reduces to this. So we have got a 2 ohms. Then here we have got a 22 over 7, a 22 over 3. 22 over 3. Then here we have got the current source with 6 amps. So that's what we have. Let me withdraw it from this part so that it is visible. So we have got this, we have got this, we have got this. So here we have got 22 over 3. Then here we have got the 2 ohms. Then here we have got the 6 amp source. So in this case, we can use the voltage divider to know the current that is going through this, and the current that is going through this. So in this case, what we are getting is we are going to get. I'll start with the current that is going through the 22 ohms resistance. So the current going through the 22/3 ohms resistance is, I'll say, current going through the 22/3 ohms resistance is equal to 2 divided by 22/3 plus 2 times what is the current there. So the current is 6. So we say 2 dividing 22/3 plus 2. So we are getting 9/7. So the current there is 9/7 amps. So but it's supposed to be a negative because now the current is changing the direction. So it has to be a negative. So we are having that as a negative. So in this case, to come up with V1 and V2, I'm sure it will be very easy for us. So it will be very easy for us because what we have is this. What we have is this circuit. We have got this circuit. So here is our V2, I mean our V1, and here is our V2. So I know that okay, I'm sure from the circuit that we have. Let me go back a bit before coming to this. I'm sure we had this. Let me split these resistors. So if I was to split them, we have got this. So before this part becomes 22/3, it is very important to look at this. We had 10/3 here, and here we had 4 ohms, and here we had 2. So in this case, so what I know is that what we must know is that the current that is going through this is just the same because we have got a series arrangement here, and the agreement is that whenever we have a series arrangement, current is the same. So the current that we have determined to be going through the 22/3 ohms resistance is the same as the ones going through these all resistors when uncombined. So in this case, the current here is so we have determined this current to be so this current is so however the current is supposed to be 9/7 amps, yeah, but for V2 here we have got V1 and here we have V2. So for V2, to come up with V2, we say V2 is simply equal to 9/7 times the resistor there, which is 4. So in this case we are getting 36/7 volts. But to come up with V1, here is the thing. So to come up with V1, we must have the current going in this direction, and the current going in this direction, we are saying it has to be assigned a negative, like I did here. So it has to have a negative if it has to go in that direction. So we are saying it is negative 9 over 7 times the resistor there is 10 over 3. So if I do negative 9 over 7 times 10 over 3, what am I getting? So I'm saying times 10 over 3. So here I'm getting negative 30. I'm getting negative 30 over 7. Negative 30 over 7 volts. So I've got so when the 6 amp source is in operation, I'm getting V1 equal to my V1 equal to 36 over 7. I mean this is my V2. This is my V2. And my V1 is equal to negative 30 over 7 volts here. Then if the 3 amp source is in operation, I'm getting my V2 equal to, so I'll go back a bit. My V2 was in, my V1 was 30 over 7, then my V2 was 48 over 7. Okay, so we are saying my V2 is, so my V2 is 48 over 7 volts. Then my V1 is equal to 30 over 7 volts. So we can add these two. So we said at the end of this, after coming up with a value when a single source is in operation, we must add their effects. So we are going to add the contribution of the 6 amps and the contribution of the 3 amps together. So in this case, to come up with a final V2, so I will add 36 over 7 plus 48 over 7. So we get 36 divided plus 48 divide 7. So we are getting 12 volts. Then V1 is equal to, so I've got negative 30 over 7 plus 30 over 7. This is equal to 0 volts. So these are the final answers according to the superposition theorem. Thank you so much.